Welcome to my video on testing two means when sigma is known, and we call that the z-test because if sigma is unknown, I'm going to use the z formula for step 2 and I'm going to use the z command for step 3, and that's why we call it a z-test. Let's read the exercise. Here, instead of writing one set of information, you need to write two sets of information because you have two populations. And the only thing that happens is you have a longer test statistics, which doesn't really matter to you since you'd be doing it on a spreadsheet. So we have a study of seatbelt use involved minors who were hospitalized because of traffic accidents for a group of 45 minors. So the first group is N1 is 45 who were not wearing a seatbelt. So no seatbelt for the first group. The average number of days spent in the hospital was 3.42. So X1 bar is 3.42. And a population, and you notice I'm going to underline that. You see it says population standard deviation, and that's how you know it's sigma, not S, and that's how you know it's a z-test, not a t-test. So population standard deviation is 2.16. Now for a group of 52 minors, so N2 is 52. The average number of days that were hospitalized, X2 bar, is 1.68. And the population standard deviation S2 is 0.86. Giving me a 0.01 alpha value, and it's asking me to verify if there is sufficient evidence to support the claim that the population of minors not wearing seatbelts has a higher mean, so mu1 is greater than mu2. The first population has a higher mean than the second population. And a counterclaim here will be less than or equal to mu2. And remember, I told you for two populations, it doesn't matter if you write original claim or counterclaim, because you can only talk about the null hypotheses in two population testing anyway. So you need to worry about OC and CC here. So let's start setting it up. My step 1 will be to set up my null and alternative. My alternative is the inequality, so mu1 greater than mu2. And my null is the equality, mu1 equals to mu2. And that's step 1. That's all we have to do for two population for step 1. You don't need to write original claim or counterclaim. Okay, now second step is I'm testing the means and sigma is known. So I will write the formula that I have to use. X1 bar, and this formula will be in front of you on your formula sheet. You don't have to memorize it. Sigma 1 squared over n1 plus sigma 2 squared over n2. So basically I have to take my given input values and I have to plug them into my test statistics to be able to figure out my z value. Now I will do this for you on a spreadsheet. So let me just write this down so I'll remember. My x1 bar is 3.42, my sigma 1 is 2.16, my n1 is 45, and my second group is 1.68, 0.86, and 52. And mu1 minus mu2 is always 0, we know that. So let's move on to my Excel sheet. And let's delete all of these and let's write the two group of information that sets the values. X1 bar, sigma 1, and N1. I think it should be a little wider. Very good. Okay, and I have X2 bar, S2, and N2, guys. Now my X1 bar is 3.42. My sigma 1 is 2.16. My N1 is 45. My X2 bar is 1.68. My S2 is 0.86. And my N2 is 52. And I have to find my z-test statistics. So it's X1 bar minus X2 bar. You don't need to type minus 0, so you just divide by the square root of S1 squared divide by N1 plus S2 squared divide by N2. And I'm basically copying the formula here. So my test statistics will be 5.07. or 5.067. 5.07 will suffice. So let's move back on to our lecture video. So I know my test statistics then is, I know my test statistics is 5.07. For a z-test statistics, that's quite large. Okay, so let's move on to step 3, which is the graphing step. As always, one population or two, either way. Step 3 doesn't change. 0. This is going to be a right tail test because the arrow in high points to the right. And I always like to draw my rejection regions in red so they can stand out, so you'll be very clear and you won't confuse where the rejection region is. Okay, now my alpha value is 0.01. Okay, and I have to find this z value, and don't forget this is a z-test, so I don't need the area in two tails, I only need the area to the left. So remember, if it's a z-test, the value you need to evaluate the critical value is the area to the left of that point. You recall that from module 5. So in order to find this critical value here, the gatekeeper, I have to use equals to norm dot s dot inverse of the area to the left. Well, if the area to the right is 0.01, the area to the left will be 0.99, so that's what we use. And if I use the norm dot s inverse of 0.99, I get 2.326. So once you use this command, you'll get 2.326, or you could just write 2.33. Now, that's step 3. Now my step 4, again, will be a decision and a conclusion. Now the decision has to do with where the test statistics falls. Test statistics is 5.7, and 5.7 is obviously in the rejection region here. So our decision is to reject the null hypotheses. And with two population testing, again, you go back to the flowchart I uploaded for you guys that made it very vivid and clear as to what you write. So for the test of two populations, if you reject the null hypotheses, you're rejecting the fact that variables are equal, or the parameters are equal, which means there is a significant difference between them. So if you reject the null hypotheses, your conclusion for two population testing will be there seems to be a significant difference between the means. There seems to be a significant difference. This is not standard deviation. Significant, maybe I should just write that. Significant difference between the means. And it's true, makes sense, because if you're rejecting the null hypotheses, you're rejecting the fact that they're equal. It means they're not equal, which means there is a difference between them, but that's how you write it. You can't say they're not equal, just like you can't say guilty. So you say not guilty, or you say there is a significant difference. And that will be step 4. Thank you.